and we've got Laurent all the way from Zurich and Stafford all the way from Sydney. like the best place to be anyway. So have we got anyone here? Post a comment. Let us know that we're actually live and someone can see us.
I can
Oh, hello, Lord Teaspoon. Excellent.
Ahoy.
Very good. We've got the usual prize giveaway, so listen closely. I'll take notes so I can think of a good question. It's good 2 questions to ask you at the end. One question is usual from each talk. So make sure you stay to the end. That's very good. Everyone.
There we go. I'm just talking to the people in chat. So you do your thing, James. I'll just pay no attention at all. Be great.
We'll come up with some good questions and ask at the end. All right. Is there anything else we should do, Richard, before we head into the talks?
No, not really. .NET 5 release candidate came out to coincide with the Ignite conference last week and so forth. So if you haven't already, get yourself a hold of .NET 5, the RC. It's pretty much baked now. Jump into it, play around with things, cause chaos, cause mayhem. EF Core 5 is out as well, and obviously ASP.NET.
And give feedback, please. Give feedback. We want feedback.
Just to learn, just by himself, just directly, he will pass it on to the appropriate authorities and do the usual Microsoft thing, which is that's great feedback, and we'll see you in 3 years.
We are better.
Not true anymore. Not true.
Come on.
Yeah, no, that's definitely old school. Actually, talking of code and open source and things like that, there was a few weeks back, there was a tweet going around just talking about some of the open source projects that with Microsoft and .NET and doing contributions. There's a whole lot of smaller bug fixes and easy entry issues that are in the various projects on GitHub for .NET and ASP.NET and so forth. If you've ever been interested in contributing to the .NET stuff in any part of the ecosystem, then definitely jump in and have a look, because there's plenty in there, and it's a good way to go, hey, I was a part of that. And it's free labor for Microsoft as well. So that's
and free labor is always, we love it. And contribution is not just about code, right? But you can also contribute to docs, for example. So if you check the documentation, if you notice an error, if you notice whatever, there is an edit button. You can click it, and then you land into GitHub as well. It's all markdown, and then you can do a pull request. So that's super useful for us.
Yeah.
And look
definitely
at
worth doing.
Free labor.
All right.
All right. Well, on that note, let's switch over to Laurent's presentation. Here we go. Oh, I'll give you. Do you want a big face or a big presentation?
I would prefer big presentation if you don't mind.
Me too. This is a new feature that's just come out, and here we go. It didn't quite work the way I expected, but now it's working. This is good.
All right. Awesome. Cool. So welcome, everyone. I'm going to start my clock so that I don't end up late. So I'd love to talk to you about durable functions, and it's really something which the reason why I made this presentation is because I actually started using durable functions for a pet project of mine, and it's performing some pipelines and all that. And in the beginning, I had implemented that with normal functions, and I noticed at some point I needed a little bit more control over what was going on, especially the order in which every function was executed. And my good friend and colleague, Anthony Chu, if you don't like him, you should follow him. He's awesome. He's a part of the functions team now, and he's my go-to for functions. So I went to him, and then he said, oh, you should do a durable function, because that's exactly what it's for. So I looked into it, implemented my stuff. It works great. I'm super happy. And then I thought, well, I should do a presentation about that. And especially when we talk about functions and all this new stuff at Microsoft, we hear often that it's done in JavaScript, Node.js, etc. And there is a little bit less material available for .NET. And .NET is I've been doing .NET since literally 2001. So it's really my passion. So I thought I would show you some examples in .NET, but just to be clear, everything I'm going to show you can be also implemented in every language that Azure Functions support, and that means JavaScript, Java, we have Python, we have even PowerShell if you want to do some monitoring, instrumentation, these kind of things. So durable functions about .NET are essentially functions. So let's do a quick reminder about functions. And functions is part of I would say, a style of programming we call serverless. And so if we do a gradation, I would say we start in the cloud with infrastructure as a service, which means you have a lot of responsibilities. You also have a lot of power, things like virtual machine. And it's essentially not different from a virtual machine that you have on your own server at home or on the premise, or parallels on a Mac, for example. It's essentially the same, except that it runs in Azure, so you have a little bit less responsibilities when it comes to networking, etc. But you still need to do a lot of things. And then the next step would be platform as a service, or PaaS, where we are going to take care, Microsoft is going to take care of more things. For example, we manage the operating system of the virtual machine on which your application is running. Platform as a service means you don't need to patch this operating system, you don't need to put an antivirus on it, etc., etc. But you still have quite a lot of power and responsibilities in the sense that you totally own, for example, the runtime on which your application is running. This is something we use a lot. For example, what we call app service, which is essentially a web application. And then the next step in the gradation, I would say, would be probably serverless. And serverless means that you don't need to worry about the infrastructure at all. It is there, okay? The old joke, which is now not so funny anymore, is that it's not serverless, it's less server, okay? There is actually a server. But really, this server, you don't have to manage it. Your responsibility is to write your code, test it locally, deploy it, and then it runs. That's pretty much it. Which also means that it's going to scale automatically. So you never have to set up scaling on Azure Functions. It's just going to happen. If you have a lot of demand, a lot of requests, we are just going to give you more instances of functions to respond to those requests. And your build as you go. It's a consumption model, meaning that you pay really by the second of what you use. Maybe there is a little bit of storage also very often because you have some documents that you want to store, etc., things like that. This is very cheap. The functions themselves are quite cheap to run because we have a number of execution per month that you can run, which are totally free. Depends a little bit on where you're set up, which region you choose, etc. If you go to the Azure pricing calculator, you can see that. But really, you can run those functions quite a bit without paying anything. And then at some point, you start paying because we like to eat. We also, I have kids. I need to feed them. So we need to get a little bit money from time to time. But it is as you go and you pay for what you need. So if you scale out very much and then you have a lot of functions because you have a lot of demand, we are going to ask you for a little bit more money. But it also means that you're going to make more money, most probably, because you will have more traffic. On the other hand, it also goes in the other direction. If the demand disappears because it's, it's night or it's vacation time or suddenly your product is not so successful anymore, which I don't hope, then we are going to scale in automatically. And again, you're not going to pay for what you don't use. So it's kind of the idea of functions. But that said, there are some limitations with functions. And one limitation is, for example, that it's going to time out after a certain time. So a function can run for a maximum of 5 minutes. And then after that, it will time out. And that can be a little bit annoying if you have a long-running task, if you're waiting for input from a user, for example, or if you just have something which is long-running. And this is why now we have this concept of durable function with an orchestrator, and I'm going to tell you more about that. So durable functions allow you, to implement patterns. And for example, one pattern that you can implement with durable functions is what we call function chaining. And what you can think about here is if you have a long-running task, like let's say you have a task which is going to take half an hour, and you cannot do that with one function because it's going to time out after 5 minutes. Then you can have instead split your tasks in smaller tasks, which is probably a good idea anyway. And then you're going to run function number one, which is going to do something. When function number one is done, it's going to pass to the second function, which is going to run, and then to the third, etc., until you reach the end. So that's one pattern that you can do. Another pattern which is really useful is what we call fan out, fan in, where you're going to have a start function which is going to run as many instances as you need. For example, let's imagine that you have a lot of small tasks to perform, and you want to wait until those small tasks are performed. Why not start, if you have 1,000 of those tasks, why not start 1,000 functions, literally, which are going to run in parallel. And then after that, when they are done, you can continue the execution, you can aggregate the result. And in that case, just note that there is no guarantee in the order of execution of F2 here. It can be run in any style, so you need to be a little bit careful about that. But the cool thing is that they all run in parallel, and we are just going to scale out as needed to run those as fast as possible. Finally, the third pattern that I'm going to show today is if you have a long-running tasks again, and you want to also get a status, and the function, the durable function infrastructure is instrumented so that you can get some URLs that you can interrogate from time to time. You get a small piece of JSON back, which tells you this function is currently running, or this function is completed, for example. So that can be also useful if you want to deliver some feedback to the user. There are actually other patterns that we mentioned, things like monitor, human interaction, aggregator. So monitor is a pattern where you have a task, like a recurring task, and you want to interrogate from time to time what is the status now, for example, something like that. Human interaction can be tricky because humans are very asynchronous. They are not very responsive either compared to a computer. And maybe they are just busy doing something. And so it can be interesting to have basically a pattern where you are waiting for input from the user. For example, the user needs to confirm an action or to deny this action, and then after that you can go. Aggregator is a pattern where you have a lot of inputs, for example, think about IoT, etc., or generally speaking, data ingestion. And this is a pattern where you can aggregate all that, store it somewhere, maybe even clean it up somewhere. You know that cleaning up data is very important. And then after that, do something. Cool. For more information about those patterns, I have a link at the end where you can go. You will see all details. There is even some code examples. But before we do that, I'd like to show you something which is a little bit tricky to understand. And so to do that, I will draw on my screen. If I can do that, let me see. Yes, cool. So one thing that you need to know is that the way that the functions work is a little bit, when you do it the first time, it's a little bit tricky to understand, because you're going to have a point of entry, which is typically an HTTP function. And then it's going to run. So it is what we call the orchestrator function. So it's going to run until it hits a point in the code where you're doing the first function. Okay. And this first function can return some data, which is going to be serialized and stored. But then after that, once this is done, the way that it works is that the code is going to go back in the start, in the run method. It's going to run again here. And then it's going to check and it will see, oh, F1 has already run. So now I'm going to go to the next step, which is F2. And F2 can also return something. So because of the fact that the functions cannot run for a long time, they had to implement it this way, in the sense that there is always a part where it's a little bit confusing, because you go back to the start and then you go to F1 and you say, oh, I don't understand because I actually already run F1. But if you put breakpoints, you will see that it doesn't actually go into F1. It's just going to go to the next one. And I'm going to demonstrate all that, and hopefully it will be clear. So let's do a demo. And so for the demo, I went into Visual Studio. You can also do Azure Functions in .NET in Visual Studio Code if you prefer. I'm personally a big fan of Visual Studio, so I kind of like it. And the first pattern that I want to show you is functions chaining. So here you see the way it works is that I have a point of entry. And this is my point of entry here. This is, I would say, a pretty standard HTTP triggered function. You may know that you have multiple triggers for your functions. For normal functions, you can have a timer trigger. For recurring functions, you can have an HTTP trigger to build HTTP APIs. You can have a blob trigger if you want to react to somebody saving an image, for example, in blob storage. So here we have an HTTP trigger, which is kind of the point of entry. And when this hits, you see it's very, very simple here and not much code. It's going to go to the run orchestrator function, which is here. And this one is an orchestration trigger. And so it's going to start automatically after the HTTP start has been hit. And this is the orchestrator. This is the most important part of your function. It's where you're going to decide who is doing what. And the name orchestrator shows very well what it does. It says, okay, first you're going to do this, and then this, and then this, okay? So here we are going to land here. We have a context object. And for the first one, we are going to do functions chaining. So remember, it's when we have one function executed after the other. And the way that it works is that I'm going to do an await because I want to execute this function first, okay? And I'm going to do context.callActivityAsync. And then I'm going to pass a string, unfortunately a magic string, which is saying this is a function that you need to call. And then we can have a list of parameters. And this function is going to return a value or not, depending on how it is implemented. In that case, it is returning a string. And so because I am awaiting this function, it means that the result of this function, I can save it in a list of string, okay? And then when this is done, here, I'm going to go to the next one, which is going to call the same function, but this time with another parameter. And then I'm going to call, again, the same function with another parameter. So let's see what happens if I run this. So you may know or you may not know that you can run the function runtime locally on your local machine, which is great because it gives you a lot of flexibility in debugging and testing everything without hitting Azure at all. And then later when you're ready, you can deploy. In this presentation, I'm not going to deploy. I'm just showing the principles. So you see the Azure runtime is starting up. And after a short wait, we see that we have an HTTP get URL, which is what you would hit to call the method, to start the orchestration. Now, you could call that from a web browser because it's simply a get or Postman or whatever you like. And in this case, something really weird happened is that it actually already started. Why did it start already? It's a little bit a quirk of functions where because you have this asynchronous run mode, when you debug and you interrupt the run, it's actually going to restart. The next time you start, it's going to restart where it stopped because the storage is not cleaned up. So it thinks that it's still actually executing. So what I'm going to do here to avoid that, I'm going to just press on continue. We are just going to ignore what is happening. And then I'm actually going to run the execution in a proper way by copying here the get URL. I'm going to go into a web browser and let me open a new one. And then I'm just going to paste that and start. And so that's going to allow me to jump into my function. So I'm back here, but this time I have a clean slate if you want. So let's run this with F10. So I'm going to run F10. Then we are going to run the first function. And this first function, my first durable function, say hello, it's actually down there. You see, this is a function. It's not going to do anything. It's just going to say hello using here's a name and then return this small string. Okay, so let's execute that. I'm going to do F5. And if I do F5, here we go. We see that we have, let's go back to the console. We have saying hello to Tokyo. So that's cool. And then after that, you see that I'm back in the beginning because this is what I was telling you about. It's going to go back to the beginning. And this time, if I split my screen, hopefully we can see that better. Now I have saying hello to Tokyo. I'm going to press F10. Okay. Now we are back at the Tokyo part. And hopefully I can scroll to just show you that. We are back at the Tokyo part. But this time it's not going to execute it because it already did. So now we are going to go to the next one. You see Tokyo appears only once. Now we are going to the next one, which is say hello to, I forgot, let me see who that was. Say hello to Seattle. And now we see say hello to Seattle. And then it goes back to the start again. So again, this is the life cycle thing that I told you, which is in the beginning a little bit confusing. But when you debug through that, you will see that eventually it's okay. And now we end up with saying hello to Tokyo, Seattle, and London. And then we end up also with an output, which has stored those strings. And like this, we have basically run functions sequentially, which is good. Okay, good. So now I'm going to stop this and I'm going to show you the next pattern. And for the next pattern, I'm going to remove this. And I'm going to go down and I'm going to show you the fan out, fan in. So this one, the way that it works in code is that you're going to create here a list of tasks. And this list of tasks, which I probably removed the using, let me see, we're going to add this. This list of tasks is going to, we are going to run them in parallel. So at first, we are just going to create those tasks and gather them, and then we'll start them at some point. Let me do that here. So here I have the list of tasks. Then after that, I'm going to say, okay, for index equals 0 to 10. Here I'm just going to do 10 times. I'm going to call or to create the task by calling call activity async. But you see, the trick is that I don't have an await here. So I'm not going to execute the task. I'm just going to get it. That's all I do. And I'm getting it by doing the same thing as before, call activity async. And I'm going to call this method, which is compute random, which is here. And compute random is going to wait for a random time. It's just a dummy implementation. But in reality, you could use that to do something which is going to take more or less long. For example, saving some reports or doing something like that, okay? So now I'm here. I just need to add the system.link, okay? And then when I have all those tasks saved, I'm going to call await when all. And when all is basically going to say run everything you have and wait until everybody's finished. And then when I'm done, I'm going to come back here. I'm going to take the tasks. This time those tasks are executed, so they have a result. So I'm going to select the result and I'm going to do toList with that, okay? So let's see how it works. I'm going to put a breakpoint here and here. Let's run that. And now one thing you're going to see in the output is that those tasks are executed pretty much in random order, not just in random order, they actually start in parallel, but because there is a random duration to the task, the output is going to be in really literally any order, which is exactly what we expect actually. So let me put that like this again. So the function is starting. It's a little bit slower than usual because I'm streaming and you know how it is, right? I have a small surface here as my presentation device. Normally it runs a lot faster. But again, the cool thing is that you can actually run that here in your local machine. Not sure exactly what it is doing right now. Maybe oh yeah, of course I need to hit the start, okay, or else nothing's going to happen. Okay, so it was my fault. So now I'm ready to run the task. I'm going to create them, and then I'm going to run them all. And as you see here, it did starting random for 0, 1, 2, 3, etc. But when I'm done, the output, which I'm going to get now, the output is going to be in pretty much any order, and it has really executed in any order because it had waited for a certain number of time, depending. But at the end, I'm able to fan in again and to gather all the results. Okay, I'm almost at the end, and then I'll take questions. The last pattern that I want to show you is very simple. It is the HTTP interaction where you're interrogating the function to know the status. And so what you're going to do here, I have a long-running function, 60 seconds, and I'm going to call this function, which is long-running. It's just going to wait for that period of time. But what I want to show you, let's run this. What I want to show you is that when you execute a function, you're actually going to get some information back from the function, including here a status query get URI. And this status query get URI here, which is until here, you can take it. So I'm copying that. I am going to call. I'm going to call here, first of all, the function to start. All right, now I'm ready to start the function. I'm going to run the function. The function is going to take 60 seconds to run. But here I have this information where I can go and hit in any HTTP client, and it's going to give me here the status of the function currently. And so here I get, it was saying it is running, okay? And now I'm at the end, actually, because the 60 seconds go very fast. So now I'm done. So if I hit the status query URI again, now it is still running, actually. But after a while, you will see here that it says completed. And like this, you know what's going on. So you have the possibility to ask your functions. So again, this is just 3 patterns that I wanted to show you. We have more than those. If you want to get more information, this is where you can go. And if you get to the QR code here, this is where you will find the slides as well as a repo, because the code that I showed you is inside the repository, so you can try it out by yourself. So hopefully this was helpful. I don't know if there are some questions, because I don't...
There are.
Okay, cool. So do you want to help me with the question? I see the chat, but I don't know what is pressing here.
Yeah. Most of the questions have actually happened just towards the end, because having someone trolling about VB.net probably isn't worth answering.
Well, we do love VB.net. God knows that Kathleen Dollard, who is the PM, is still very active with that. But yeah, those are C#. This is C# stuff. Yeah.
All right, so
So I see
noise ratio
and Service Fabric. And I would say the usage is probably quite different. And really, like for example, Service Fabric is more of a microservice thing, and I wouldn't compare durable functions to necessarily a microservice architecture. It's a little bit different. The usage here in functions is really when you want to have a serverless model, like it's really aimed at serverless models, but you want to have a little bit more control over what happens compared to a standard function pattern where you have, for example, HTTP trigger, timer trigger, or whatever, but you don't really have a fine control over what's happening. Where I use durable functions at the moment is to build pipelines. So I have some continuous integration systems, for example, my blog, or a project that I'm working on at Microsoft where we're processing some Markdown. And the Markdown, there are multiple patterns that I'm using there. The fact that I'm using serverless for that makes me happy, because it means that I can just deploy and forget. I don't have to manage anything. But of course, the orchestration that you mentioned is true that you have to implement it, but that's during the implementation phase, right? And then you're done. Basically, it's going to run on its own. So it's quite nice from a peace of mind standpoint. And the patterns I'm using there are function chaining, because I have to do multiple things after another, but also fan in, fan out, because I have a number of documents. For example, in a blog, you may want to create some HTML from Markdown, and you may want to update the HTML, for example, with a previous and next link. So you need to go through a number of documents and maybe update them like that. So that would be a fan in, fan out example. So I would say the usage is very different. One thing true about Azure and about Microsoft in general is that we have so many services that sometimes they overlap a little bit. And that's true. But I would say really let's go and check the durable functions is a little bit more, probably a little bit newer than Orleans or Service Fabric. Also, Service Fabric is something that we still maintain. We have not been promoting it as much, I would say, compared to, for example, AKS, Azure Kubernetes Services, etc. But anyway, yeah, there is definitely a choice. This is just function and just from a serverless standpoint. Hopefully that answers the question a little bit. Execution environment for durable functions in Azure. This is a great question. So the answer is literally you don't care. You can choose between Windows or Linux for the runtime. And it is essentially... So if you run this on Azure, you will have a server which is running, but you don't manage it at all. It's really infrastructure the infrastructure is completely taken care of by Microsoft. And the only thing you have control over is if you want Linux or Windows, and what version of the framework you want. For example, if you select Node, you can select the version of Node. If you select .NET as well, .NET Core, of course, because it's Windows or Linux, right? And Java is the same thing. But that's like the control you have. The rest, whatever version of IIS is running, is it really IIS or something else? Is it Linux or whatever? That's not your responsibility, but it's also not your control. Okay, you relinquish control by choosing serverless like that. Hopefully that answers the question. The clunkiness it's an interesting comment. I felt that as well, so I'm going to be totally open with you. Those who know me know that even though I actually get a paycheck from Microsoft, I'm not embellishing the thing. I think that it has a lot to do with, I would say, first of all, the asynchronous, like the intrinsically asynchronous model that we have for that, and also the compatibility with other frameworks such as JavaScript, for example. And there are a few things like the magic string, which I don't like much, right? There are a few things like the fact that it goes back to the top every time confused the hell out of me in the beginning. I was really like, what's going on, dude? Like, how do I even debug that? And once you understand what's going on, then it makes sense. But also you need to keep in mind that, for example, whatever the function returns need to be serializable, because if it's not, it's just not going to work. You're going to get an error. If it's not serializable, then, well, essentially it cannot be serialized, like the name says, and then it's going to fail the execution, because every time that a function comes back, the code stops, right? And the result needs to be serialized in storage. And so you need a storage account for that. You will see in the storage account that you have a container, which you should really not delete, because otherwise nothing's going to work anymore. Where you have some things which is stored about the function execution and all that. Let me see. Yeah, I think we've been.
I think we've got all those questions covered, which is
good question, good feedback. I was just reading, and I'm not privy to the really the implementation details, like in the very deep. But if you have questions like that, you can always talk to two people who are amazing. Jeff Holland, so Hollan, who's on Twitter, and Anthony Chu, who I mentioned before. And myself, I'm L Bugnion on Twitter. My DMs are open, so if you have any questions that you want to ask me, please feel free to ask anytime. Thank you so much for your attention.
Fantastic. Awesome. Thanks, Laurent. In terms of switching across, we were going to give everyone a massive break of about 2.5 seconds while Stafford gets ready. Oh, look, Stafford's ready to go.
Are you ready, Stafford? Share your screen and I'll put it on. Thank you very much.
I've shared my screen.
Quite informative. All right, let me.
Groovy. Okay,
Captain James.
I don't have any slides, so I'll just talk a little bit about me and then we'll jump straight into it. I'm Stafford. I work at Telstra Purple as a software consultant. I'm on that Twitter, so go to staffordwilliams.com and add me to your Twitter as well. And we can, I don't know, talk about nerd stuff on that platform. But for tonight, let's talk about some nerd stuff on this platform, specifically .NET TIE. And what is .NET TIE? Well, I'll tell you. That's why I've been invited this evening. David Fowler, I think, who of like Signal R fame, and Ryan Novak of, I guess, most recently Blazor fame. The two of them started separate projects at the end of last year that kind of made it or smoothed the path from a .NET project into Kubernetes. And those two projects merged and became what is called Project TIE. It's open source. It's been around since the beginning of this year. The important part to note, I think, is this bit right here. Project TIE is an open source experiment that will last until November 2020. So no promises is what that says to me. Don't use it in production. I'm I did use it at a client, but it wasn't in production, so that was allowed. But I have contributed to this repo. It's fun and easy to jump into and contribute to if you want to. What we're going to do as part of this talk is jump into, we're going to jump into, there goes my password thing. I'm going to hide that. We're going to go from empty command console to running in Kubernetes. And I just want to point out that I'm running this, and I've got .NET on my machine, and I've got an empty cluster. There it is, sitting there, waiting for us to go. So I'm going to go make the Thai talk. I'm going to jump into there, and I'm going to do .NET new MVC in front end. So we're going to create just a quick little MVC project that we'll call front end. Now, what Thai does is it lets us easily kind of manage and create .NET-based microservices on our local, and then push them both to container repositories and also to Kubernetes. So there's our front end there. We're going to add Thai to this little thing that we've got here. Thai is, in fact, a .NET tool. So probably a lot of us know we can add .NET tools globally. I'm going to add it locally because I think it's cool to do so. So we're going to go to do that. We need to do what's called creating a tool manifest. And what that's going to do when it's finished is it's just going to add this little config directory there. And if we have a look at what is in that config directory, we can see that there's just one file and all it's got is that. Not very special. But now we're going to add Thai to it. We're going to go .NET tool install Microsoft.Thai. And it is a pre-release package on the NuGet feed. So you have to specify the version. So we'll do that now. There it is. And look at that. And if we have another look at what it just did to that file, it just chucked that in there. So if you haven't used tool manifest locally before, it's just a cool way that we can store in our local source control the tools that we're using. So then other developers can just go .NET tool restore, and magically those tools appear on their machine without having to install them globally. So we've got Thai in there now. Cool. What does it do? Let's run our front end project. So it's popped up something on localhost 8000. Let's go and have a look at that. And there it is. So there's our front end project there. We've got some interesting stats, I guess, stats in there. But importantly, there's some logs over here. These are real-time logs. I'm presuming there's SignalR involved in there. But also, it's given us these bindings where it's brought this project up. So if we come and have a look at one of those, look at that. There's our MVC project that we just newed up. So wow, absolutely amazing. Yeah, not really. So let's make it a little bit more exciting by adding more stuff to it. So we'll kill that, and we'll add our. We're doing microservices, y'all. So let's add another service and have these two talk to each other. So let's go .NET new. We'll chuck a web API in there, and we'll call that the backend, the mighty backend. When that's done, what we can do, or what we did do before when we ran Thai, was we referenced the project directory. But we don't want to do that every time, especially now that we've got two directories. So what we in fact need now is a solution. So we'll just quickly add a solution in there. We'll add both of those projects to the solution. Front end, back end. Look at that. And then we'll try it again. .NET Thai run. And up pops our little friend again. Let's refresh that dashboard and see what we get. And funnily enough, there's now two in there. So with one command, I brought up both projects. So .NET's in tie in the backgrounds, in fact, running both of these. We can go and check out what the backend's doing as well. It will throw 404 because if you remember or are familiar with how that web API works, it exposes, I think it's weather forecast. There you go. There's some weather forecast. So if I refresh on that, we can see it's generating new data. Okay, cool. We've now got 2 projects, 2 microservices running in .NET TIE. Cool. What's next? Let's kill that. And let's connect the 2 and have them talk to each other. So what we're going to do is we're going to jump into the front-end project and we're going to add a couple of libraries that are going to help us. So one of them is going to be, I just tried to tab complete that, but it doesn't work. One of them is going to be Flurl HTTP. That's a really cool library where we can just make HTTP requests directly off strings. We'll see how that works in a moment. And the other piece is the package that will let our front-end project kind of magically discover where the back-end is. So that project is, in fact, Microsoft.tie. You know what? I'm not even going to type that. I'm going to paste that in there because the same idea. It is a pre-release, so I've got to put that version in there as well. Okay, good. So we've added those 2 projects to the front end. I've jumped back here, and now we're going to open up our editor, which in this case is Visual Studio Code. We will put that over there, and we're going to go to the front end. We're going to go to Startup, and we're going to add. We're just going to add in the same file because YOLO. We're going to go public class. What are we going to call it? We're going to call it URLs. This is where we're going to store the different URLs that these services will talk to each other on. So we'll go public string backend, and that's the only. All that's going to do. Don't ask again. The only thing that that's going to do is hold that URL for us. Then in, I believe, somewhere around here, we're going to go. What are we going to do? We're going to add a singleton. And it's going to be our new URLs. We're going to set, and this is where the magic comes, backend equals configuration.get service URI. And we called it the backend. And this thing is going to return a URI, so we're just going to string it. Cool. Why have I got a squiggle? I've got a squiggle because I got a typo. Squiggle should go away, and it does. Okay, good. So what that's going to do when it comes up, it's going to go and, because of that configuration package we add, it's going to go and find the URL for that backend project. Now we're going to jump into a controller, specifically this front-end controller, and we're going to inject that URLs object. Now we're going to be very naughty and just use from services. Is that naughty? Method level injection? I don't know. If you can do it though. So let's go URLs. We will. Oh, where is it? Here we go. So that'll inject that in there. And what will we do? We're going to get our weather forecast. We're going to go, we need to chuck in our little Flurl thing. So this is where we're going to be using flurl.http. I think I'm going to end up using both of these namespaces, so I'll put them both in there. And when we go urls.backend, that's our string, which represents our, so we can just make requests directly to that URL. So let's do exactly that. Let's, you know what, let's chuck that down there. And then go append pass segment. And if you remember correctly, when we're on that web API for the backend, we got a 404 on the first. I'm seeing now Richard Banks's comments. On if you remember correctly, we were getting a 404 on that back end on the route. So we've got to chuck in back end there. And that there is in fact Flurl. And also this bit is here, which we'll go get JSON async. We'll tell it that it's coming in. Oh, I forgot one thing. In the back end, it sends us back. There's this model. That's how, when we were refreshing it, that's how those things were coming back across the wire. So we're going to kind of steal this. Let's just copy and paste this bad boy straight into the front end, into models, I think. But like if we edit it, it's like we were actually writing code. So we'll edit it as well. Look at that. Oh yeah. Oh, look at that though. We need to change this to front end. Yeah. Okay. Oh, and I got rid of a squiggly. Put that back. Should be good. Yeah. Okay, good. There's our model that we're going to get back. Now we can go back to our home controller. We can say, do you know what? It's coming in as a weather forecast. It's going to come in as an array. So we'll need to chuck that in there. It should be able to find that. Maybe I need to build it. Let's try build. Try build at this crazy point. Come on. Now build. We did have a problem. What was our problem? We were missing a semicolon. Very naughty. Ah, because we're not finished. Let's finish first. Let's go like that. That should make that squiggle go away, I'm thinking. Yep. Okay, good. So we got build. And then what are we going to do with that once we've got it? So when this thing runs, we've got in here our array of weather forecasts. So let's do something with it. Let's use that horrible dynamic container called view data, and let's stick in it weather forecast. We'll just put the first one in there, and we'll grab the summary out of it. Cool. I think that's going to be good for us. Why are we getting squiggles? Build again. Squiggles cannot apply indexing. Why can't we?
It's a task you might want to await.
Oh, thank you. It is too. So what we want to do is chuck an await in there, and we want to chuck a task there. Maybe an async as well.
Should have been one of our questions for the end, James.
Look at that. We got to build. Okay, so there's our controller. And the last thing that we will do is we'll ninja over to our little, here's our welcome screen that we were seeing before. And let's just make a call directly to that view data and go summary. Cool. Okay, save that. Save. Yep. Okay, cool. And let's go .NET Thai run. See what happens. I'm hoping it's going to build. I didn't do the last build on it, but it should. And I'm hoping that it will bring up both of those services, that they will magically connect to each other because of that configuration package. And that we'll see the results of that right now. So refresh on this guy. And let's go and look at that front end. Oh, that's not good. 404 not found on that back end. What have we done wrong? Just make sure that the back end came up. It did. Have we got the path wrong? Get rid of that. Look at that. We stuck back end in there instead of weather forecast. The URL is weather forecast. So let's do that. Let's kill that. let's bring it up again. Okay. Refresh on this. Have a look at this. Close those right ones, I think. And look at that. We've got mild in there. And look, when I hit refresh, it's replacing. So Ty's brought up both of those services. We told it in startup that that URL was backend, was just a service called backend. And then in that controller, we called it. Okay, that's cool. What can we do next? Well, do you know what? Let's push this to Kubernetes. What, you say that's crazy? No, that's not. Do you know what? Here's an empty cluster. We looked at it before. Let's just push this right at the cluster. So I'm going to go .NET Tide deploy. I'll put that little I in there because it means run it in interactive mode. So this would fail if I hadn't put the I in it, and it's because it doesn't know which container registry it wants to push these containers at. What containers, you say? Yeah, so in the background, Ty's going to grab those projects, it's going to stick them in a container, it's going to push them to a container registry, and it's going to push those containers to our Kubernetes cluster. Well, there's no way it's doing that, you say. Well, you know what? Let's have a look to see if it is. That's my Twitter handle as well as my Docker Hub container registry. This probably will end up taking, I think, about a minute and a half. Once things are cached, it ends up taking a little bit faster. It is like if you're used to pushing Docker images to a container registry, with like when you go Docker push, you'll be used to seeing those layers that it pushes. Ty right now is hiding those layers one by one, so that's not ideal. When it does pull containers, which we'll see a little bit later, it does show the layers and give you an idea of progress. But we can see what it's done up here. It's doing it one by one. It's done the front end first. It's compiled it. It's created the image. It's pushed the image. It's done the same for the back end. And now it's of the opinion that it's running in our cluster right at the end here. So, of course, we don't believe that. So let's go get all as well. And wow, there's a lot more happening in the cluster than there was before. So maybe it did happen. Let's port forward to something, perhaps the front end. And we'll do that by going like that. And let's go and see what that front end's doing. So we'll check on that. And look at that. Like I've just port forwarded from my local to that Kubernetes cluster, and those two containers, which both have my .NET microservices inside them, are running. Are they talking to each other? Well, I think so, because it ran that one. Let's go Control R on, and it's updating. So we've definitely got integration. That's pretty cool. Let's go a little bit further again. Let's kill that, and let's go .NET Ty init. Now, if you remember, I haven't really configured anything about Ty. The only thing that I did was installed the tool, which I did via that manifest bit. I didn't have to do that. I could have just installed it globally and then gone, hey, I could just run Ty wherever I want and magically push .NET projects to Kubernetes. Wow. But let's have a look. If we needed to maybe configure some things and determine or have more fine-grained control of how we're using Ty, then we need to create this init file. So we'll go like that. We'll go Ty init, and then let's have a look at what that file looks like. There it is. We'll kill that. We'll kill that. So what has it done? All it's done for us is it's created that based off the solution or directory name. I forget which one. But it's added our two services, one called front end, one called back end. Now, the first thing that I can do in here is I can jump in here and I can go registry Stafford. And now that I've done that, I can save to source the name of my registry. So as long as whoever's running this code is authenticated with my registry, they can just go .NET Thai deploy, and we don't have to run it in that interactive mode anymore. That's what takes care of that. Now, when we ran in Kubernetes, we had to port forward to it. It wasn't publicly exposed. Wouldn't it be cool if our microservices that we created only minutes ago were just magically available to the public inside our Kubernetes cluster? Yes, I think that would be very cool. So let's do that. Another feature of Thai is ingress. So if you've ever set up an ingress in Kubernetes, when there was no ingress in Kubernetes, there's some steps, maybe like 20 or something. But Thai is gonna attempt to do that all for us. So I've specified an ingress here. I've given it the very cryptic name of ingress. And I've said, you know what? Bind port 80 to these two paths. The root will be our front end and the API will be our back end. So let's just save that. What was that? If I just hide the window, maybe it didn't say that. Good, problem solved. I don't know why it's doing that. Anyway, I'm pretty sure it saved that though. Let's just check that it did. Should be in here. There it is. Cat.yml. Yeah, it saved it. So let's go .NET Thai deploy. So now we're doing it without that I. Now, this is going to do the same kind of thing. It's going to build those projects. It's going to push them to the Kubernetes cluster. So it's going to push them to the container registry. It's then going to deploy them to the Kubernetes cluster. It's doing it, I hope, slightly quicker this time. Maybe the same speed. No, slightly quicker. So it's cached some stuff. There's that back end pushing that Docker image. And there was another extra little step in here. And it's that ingress right there where it checked the ingress. Now, I lied to you earlier when I said that my Kubernetes cluster was empty. There was, in fact, an ingress that had been added by Thai already in there. The reason why I didn't do it here is because it takes 2 to 3 minutes for it to set up. But if we go kubectl get ingress, if the ingress wasn't there, Thai will set this up for you based only off that config that we gave it. When we query that ingress, we can see that this is the IP address. So let's just copy that directly into here. And wow, look at that. Publicly available on the internet. Cool. Okay, so cool. .NET projects running magically in Kubernetes, or maybe not magically, just very, very quickly. So there's two last things that I want to do. One is talk about, do you know what? It's not just for .NET projects. What if we have containers written in other languages that we want to be part of this microservice ecosystem that we're building? Thai will help us with that as well. So if we drop into services, we can stick another service in here. I've just called this one Hello World. It just is going to pull this container. This container listens on HTTP, and it just responds back any information that you stick in the URL. That's all it does. It's going to listen to port 5050. This kind of binding is very similar to what we'd use on that. To what we'd use in like that port configuration in the Docker run command or Docker compose. So we're going to hit save on that. I don't know why this thinks Salesforce CLI. Yes, folks, I taught myself Salesforce. I don't know why that thing's complaining though. But we'll just ignore it. So we've added a container. What do we need to have that container talk to us? Well, we need to do a very similar thing in that we need to get this config thing to tell us where or what that URL is going to be when it runs both locally and in Kubernetes. So let's stick another thing in here for our container. We'll just go whoop like that. We'll change that to container. We called it, I believe, Hello World. I think it was. Was it? Yes. So we've got that hello world, and once it knows where it is, it's going to be available here as well. So I'm going to use or I'm going to use Flurl again. I'm just going to copy and paste this code though, rather than watch me type it. I'm going to get rid of that. So, and we change that to container. So very similar to the top one, just grabbing that container URL that's going to be set at runtime. We'll change that to altnet. And then it's just getting a string this time. We'll stick in that view data called hello. So then let's go and have a look at our index, and let's expose what we just stuck in there here as well. So let's go hello. Good. Save that. Oh, I keep hitting save and it keeps making that Salesforce thing come up. We're now going to go .NET Thai run. And the idea here is that now we're running 3 microservices. We've got the front end, we've got the back end, we've got the container. It's going to bring all 3 of these up. It's going to connect them, and it's going to let us debug locally all of those things. So grabbing a whole lot of logs as well. And if we go and look at our dashboard, it's actually added a service in there for the ingress as well. We're not going to use that though. Let's go and have a quick little look at what this thing does. It's not doing anything. Still, container still come out. There it is. So I can type in Richard in there and it'll go, hello, Richard. Wow. So let's go and open our front end and see what it's doing in there. And there we go. Look at that. We've still got that back end updating at the front there. And there's our text that came directly from the container. So cool. There's one last thing that I want to do. And that's talk about the idea that, okay, so Thai represents this really easy way for us to work with containers, to make microservices in .NET, to get them running on our local, to push them to Kubernetes, push them to Docker, etc. But the push them to Docker bit is an interesting part. Let's kind of forget about microservices for a sec and look at this last possible way of using Thai, which is let's go say hi in here, and we'll jump into maybe say hi, and we'll go .NET. Oh, actually, you know what? I want to remove say hi, and I want to go .NET new console say hi. So let's just make a console application. So our good friend, the console application, we run it and it does stuff. And the stuff it does is what we tell it to do. Wow, that's it. What a great relationship. Let's jump in there and let's go code on this one. So imagine this is a program that we've created, and we've added whatever our task that we want it to do. We've written it in .NET. In this case, I'm just going to tell it to say hello back to us. And then let's .NET run, I think, altnet. Can I do that? Okay, so that's all that this thing does. But the important thing is we wrote it in C#. It could be doing whatever we want it to be doing. And we're going to use Thai on it now. What are we going to do with it? We're going to go .NET Thai push. And I really like this command, and it failed because we don't have Thai.yaml. Should have that. So it lets us really quickly just take any console application that we've got, package it into a container, push it at the container registry of our choice, and then we can then just go and run that console app on any Docker-enabled host on the entire planet, and possibly other planets once they have internet connections as what now. But for now, just planet Earth. So what I've done there is I've pushed that thing. Now I can get out our friend Docker. I can go run Stafford, say hi, like .0.0, and I'll put my name in there. No, I'll put James' name in there. And look at that. Immediately running .NET code anywhere on the planet just with .NET ties. So that's all I've got to show you, folks. If you've got questions, please ask them.
There are questions. I'm just scrolling back up unless James gets there first. Is there a tie equivalent to a .NET Watch?
Excellent question, because there didn't used to be, and it was very annoying. You probably saw me when I made that error, which is, I mean, I hardly ever write bugs or make mistakes in writing code because I'm so pro. But when you did on stream just see me make that error, I had to kill tie and then bring it all back up again. If you had a lot of microservices in there, that's obviously going to take some time. In the early version of tie, that did take some time, and it was one of the reasons I stopped using it on a client project that I was using it on. But since then, I think since version 0.2, there is now .NET tie run watch. And the idea with that is that it will watch the projects, or all the projects. So if you had multiple projects in there, if you change any of them, it will just reload the ones that changed rather than pulling everything down again.
All right, that's cool. AB was asking if it also supports working with environment variables, and then poked his tongue out for some reason.
Yeah, good question, Abby.
Sure.
I've got no idea. So go Google that for yourself, mate. Do you know what? I'm gonna make an educated guess though. I think that it does, and I'm gonna say that I think that. And when you say environment variables, you probably mean in that tie config. I'm guessing. I think that it does. Sorry, Ibby. Me and Ibby go way back. That's why I'm taking the piss out of him. I'm not just a complete asshole. Oh, I mean, yeah, I'll leave it there.
You know, within reason. Andrew was asking, or Nose Ratio was asking me for if you think tie is going to have life after the experimental period is over.
Yeah, that's a good question. I think, like all things, it will be down to both the usage that it has and the contributors that jump in there and do stuff with it. When the project launched, they said that they were looking at targeting a release every 4 weeks with new version, with new functionality each 4 weeks. That continued for 4 releases, and I think the last one was in July, and there hasn't been another one since then. So I don't know what's going right now. I don't know, and I don't know what will end up happening with it. It is a .NET Foundation project, so I don't know if that adds any credit or likelihood that it will stay around if Microsoft people just become bored with it. I don't know. But it's quite small anyway, so it's fun to jump in and play around with and just like fork it, I guess.
I think we had all the other questions earlier covered, unless there's anything else that comes up in chat in the next few minutes.
Yes, the only thing we can say about it is that there was a great presentation, by the way, I really liked it. But Scott Hunter, who's the lead of .NET, made a presentation at Ignite last week. And those presentations are all recorded and available for free. And he was also showing tie stuff. So that can be also interesting to watch. But I like
Thank
yours
you.
better.
That's very kind of you to say, Lauren. I will give you that money that I told you I'd give you afterwards. One thing that I did see today as well is that last release that did come out added Azure functions to it as well. So it would be interesting to see how we can integrate that local experience with Azure functions directly via that tie YAML as well.
Hey, Steph, a question for you. How do you think this fits with things like the bridge to Kubernetes thing that's come out recently?
I don't know if I know bridge to Kubernetes. What does it do?
It's basically
This is the
you have
Microsoft one, right?
Yeah, you got a dev cluster for Kubernetes, for example. You got stuff sitting there, but you can just run one of the containers or pieces locally, and then basically it hooks itself into your remote cluster or wherever it happens to be, so you can run one part of it with everything else going on.
I do remember briefly skimming that article. I haven't tried that myself. It seems nice. It obviously, though, does mean that that's going to work great for you if you've got a chunk of services that are in the cloud, like and running in your own cluster and that kind of thing. I don't know. I don't know if it's because I'm older or not, but I have this strong desire to be able to run everything on my local. I feel like I've got more power over it when I've got everything on my local. So I guess, but I mean, cloud and access to people just running their own clusters and own infrastructure in the cloud is whatnot's becoming so ubiquitous that maybe it will start eventually not making sense running on a local. Maybe there'll no longer even be a local.
Well, that's already there with code spaces, right? Yeah.
Yeah, you could say.
Why not with 32 gig of RAM? What, the cloud with 32 gig of RAM?
Interestingly, this laptop's only got about 16 gig of RAM as well. So
it's tiny. It's hard. Like, that's an embarrassment. There's more memory in your phone.
That's true.
Yeah. All right. We might pause there unless there's let's try compiling Chromium in cloud. Cool.
Actually. So.
Yeah, James, you want to jump in with the infamous giveaway?
All right. So we've got the 2 JetSbrain licenses to give away. Sorry, Lauren and Stafford, you can't answer these questions because they're on your talks. Unless you answer on the other person's talk, then you could perhaps do it. All right. But the two exciting questions, well, we'll start with the first one. So what are 2 of the patterns that Laurent mentioned in his talk? He mentioned at least 3, so you only need 2.
I feel like we should be playing like tick, tick, tick music or something, like Who Wants to Be a Millionaire or whatever it is.
Or something. Oh, look what we got. Lord Teaspoon, how many licenses have you got?
Boom. The correct answer is always 0. You know that.
Never enough. All right. That's very good. I think you deserve a license. And the other one on Stafford's talk is, what's the command line to deploy your stuff to Kubernetes? Stafford showed it twice, once with a -i and one without a -i.
Whoa! Don't make it too easy. Don't give it away.
Otherwise, I've got a backup question if no one.
If I've got the URL that's the answer to Ibby's question, how can I paste that so everyone can see it? Do I have that power?
If you can. Well, are you?
Or if you just show my screen, you can see it, the URL on my screen.
All right, I can do that.
So no one's answered James's question yet, though. Still waiting.
Oh. Well, I'm giving them time to think about it. There's the answer to your question, Ibby. You see that URL up the top? That's the schema of Thai.yaml inside the Thai repo. And right there and highlighted for you is environment variables. I don't even need to Google that.
All right. So has anyone got an answer to the second one, or we have to go to the backup question? Or Lord Teaspoon wants to have a second license? I think we usually limit it to 1 per session. All right. So the backup question is, the Thai experiment lasts till at least when? I think it was mentioned twice. Maybe these questions are all too hard. There you go.
There it is.
All right. Very good. I think that's the answers there. So as usual, just send me. I know, but you must need another one, right? There's a lot of JetBrains products.
They're not for resale, just so you know.
Yeah, probably.
Yes, it was.
So now that you've got the answer to the other one, yeah,
that's right. Deploy. So
Very
hard. So hard.
Okay, well done, everyone. And thank you very much to our speakers. I enjoyed both talks quite a lot. And
Yeah, thanks, Lauren.
any volunteers for speaking as well, just let us know as usual on Meetup, Twitter, whatever. And we'll be back for you next month.
Indeed, we will. Thanks, everyone, for jumping on the stream and talking rubbish occasionally. We will catch you all next month, as James said. In the meantime, play with .NET 5, pay attention to .NET Conf coming up as well. Put that in your calendars in November, the big launch. And as always, we are here for you. It's your group. Let us know what you want. Until then, we out. Happy coding, all that sort of thing. Hit start.